Okay, yes, now we are focusing on this. We are still looking at this message. It says week 8 material. So let's talk about week 8 material, and this is going to be probability. Let's quickly go through it as fast as we can, and we see how it goes. Probability, remember, it's just the chance that an event will happen. So we're going to look at keywords, then work from there until we see some calculation questions, and then we'll see what to do with it. So the first thing to know is some of the words which you're going to use. Number one is an experiment. What is an experiment? It is going to be a process that produces outcomes, a process that produces data. It produces the data we need. So it's like flipping a coin, okay? It is either going to give you a head or a tail. So it's a process. It's a process that produces outcomes where the result is uncertain. Even if we know the probability of the result, we never know which one are we going to get. Because if it's not if the event does not have the probability of 1, that means yes, we know its probability. We know that there's a 0.5% chance of happening, but we don't know if it's going to happen. You get what I mean? So it is a process. It's a process that produces outcomes. This is an experiment, okay, or that produces data. Some action that you do that is going to produce outcomes where the result is not known for certain. Where the result, we didn't say where the probability is not known. No, you know the chance of the result happening, but where the result is not known for certain, we don't know the result. Now that is an experiment. Now, a sample space is going to be a set or the set that contains all the possible outcomes of the experiment. This is going to be of an experiment. This is going to be your sample space. So a sample space is the set that contains all the possible outcomes. Then an event is going to be a subset of the sample space. So it's not going to be all the possible outcomes, but it's going to be some of the outcomes. That's why it's a subset. So an event is going to be some of the outcomes of the experiment, okay? Only some of the outcomes will be there in a subset. So that is an event. An event is going to be a subset that contains some of the outcomes. Now, from here, so we've seen those 3 keywords. What we saw what an experiment is, it is an action that produces your outcomes, okay? Then now we are saying, and we saw that a sample space is all the possible outcomes, and then we saw that an event is a subset of a sample space, which is some of the outcomes of your experiment. Now from there we can go on to the types of probabilities. Now the types of probabilities that we have are 3. Number 1 is the classical or theoretical. When you say classical or theoretical probability, it is a probability that is calculated or that is gotten based on logical reasoning. It is based on reasoning and math, on calculation, okay? And what makes us be able to do this type of probability, the classical or theoretical, what makes us be able to reason it out and be able to find the probability is because that the outcomes are equally likely. It's like spinning a coin. There is a 50% chance of getting a head and a 50% chance of getting a tail. But it is not like dropping a bottle. When you drop a bottle, we know that it usually wants to, especially if it's empty or whatever, it likes to fall sideways. So this has a higher chance that it will fall sideways than that it will fall straight up. So this is not 50-50. So that is not a classical or theoretical probability. For theoretical probability, 2 things must happen is, number 1, it is based on logical reasoning, and number 2 is that all the outcomes are equally likely. Then we'll be having classical or theoretical probability. Experimental probability, it is the probability that is found by performing an observation or performing an experiment. So this is a probability that is a probability that is found from performing an experiment or from an observation. Then subjective probability, it is based on opinion or an experience. It's the type of probability like if you say, I see that there's going to be a 40% chance that it's going to rain. Maybe you have been studying rain and whatever, and you now know things that to look for. We know that make you know that it's about to rain. So you can say it's a 40% chance that it's going to rain. The next person may disagree with you. Okay, so it varies from person to person, this subjective one. Subjective, it is subject to the person. It is a guesswork type of thing. It is based on your intuition or your belief, or it is based on your experience. But it varies from person to person. But the experimental is the type of probability that is calculated based on actual observations. It is calculated based on actual observations or experiments that have happened. Now, These are the types of probability. From there, we now go to the types of events which we are going to use to kind of find out also the probabilities for that event. Number one is the types of events. Let's go through the events. Number one is going to be an impossible event. If you have an impossible event, it is just an event that cannot occur under any circumstance. Okay, an event that cannot occur under any circumstance, we represent it by the sign of the empty set. This is an impossible event, and the probability of that event is going to be 0. Probability is 0. It has a probability of 0. Probability, you don't write it as a probability of n. You can't say the probability is equal to the empty set. No, the probability is a value which is going to be equal to 0. Then that is for an impossible event because it cannot occur under any circumstance. Then a certain event is an event that is guaranteed to occur. It is always going to happen. It has the probability, we use the sample space sigma. There's a probability of 1. Okay, so there's a probability that is when you know for sure that an event is going to happen, then the probability is going to be 1, you're guaranteed. Then now we go to simple event. A simple event, it is just a single outcome from an experiment. A single outcome, that is going to be a simple event. A single outcome from an experiment. And here we can now get the probability of that event. And it's because these events are usually represented by capital letters. So an event is usually represented by a capital letter, and here we have capital letter A to represent a simple A. Okay, which is a single outcome from an experiment. It is just going to be equal to the number of outcomes that are in set A, which is the event itself. Then we divide by the number of outcomes in the sample space. Then this helps us to know the probability of that. Number of outcomes in A divided by the number of outcomes in the whole thing. This helps us to know the probability of the event. Now, what about a complementary event? Okay, a complementary event here. So we've talked about the simple event. It is a single outcome. Certain event is an event that is guaranteed to happen. This one is an event that cannot happen, impossible one. It's an event that cannot happen under any circumstance. Then a complementary event. We say a complementary of an event. It is when you have all outcomes in the sample space. If it is when you're looking for all outcomes that are in the sample space but that are not in that particular set. Okay, so if we say a complement, we want all outcomes that are in the major set, but we don't want them that are in A. It's the all outcomes that are in the sample space but not in A. So the outcomes that occur when the event does not occur, these are going to be your complement. For your complementary event, it produces outcomes, or it is when you have outcomes, because event is a bunch of outcomes, right? So a complementary event is a set of outcomes, okay, that does not occur, okay? It is a certain outcomes that occur when the event does not occur. So when the event does not occur, then these are the complement, okay? The set of outcomes that occur when the event does not occur. You see, and that is going to be your complementary event. And when you write the probability of a complementary event, this one you need to remember it, that the probability of a complement, okay, or which is equal to just the probability of a complement, it is going to be equal to the 1 minus the probability of A. This gives the probability of not A. It's 1 minus the probability of A, then you have the probability of not A. This is going to be complementary event, okay? This is going to be your complementary event. And from here we can also say that, we can also just say that, no, it's fine, we can leave it like this. It helps us to know. Now when we have complementary event, if we were to draw it on a diagram, we can show it like this to say that this is going to be inside here, you shade, this is going to be A. Then if we draw it like that, then it's going to be like this, then we shade this other part, and this is going to be called AC. Okay, this is the inside, it's going to be a complement, and that is what you must know. Okay, and this is going to be your complementary event, 1 minus the PA. Okay, then you're going to have it, right? That is not a problem. Remember that that this is something which is outside of A. When we say A complement, we are taking outside of A, but we want within the sample space sigma. Okay, that is important. Now the thing is, we have done this. Then we are now going to number 5, which is going to be compound events, and it's going to be quite long. It's not too long, but it's just going to make us wake up, make us just look forward to it. So that is it. We're going to do the compound events going down in the next video. Goodbye for now.